Morning. So I heard school loop is down. This is still down. Alright. Well, if you haven't printed the thing yet, the notes yet, you can just follow through with the notes and you can fill it in later, okay? You know, because video is always available after this anyway, so when it becomes available you can just, you know, recopy all the notes, but just follow along. I think it makes a lot of sense if you just follow along and practice the problem together on a piece of paper. Okay, so get that ready and we'll start in 1 minute. Okay. Do you have everything ready? So we get started. All right, shall we start? Today we're going to talk about, this is actually going to be blended between 11.5 and 11.6. So, we're going to basically talk about prism and cylinders, and then we're going to talk about pyramid and cones. They're very similar, so I figured that I'm going to talk about them together. The homework assigned is only on 11.5. Next week it's only going to be on 11.6. But today, this week and next week, between this week and next week, we are going to talk about all of 11.5 and 11.6. So we're splitting the two sections and remixing them into 2 weeks. So some parts that I'm talking about is going to be 11.5, some parts are going to be 11.6. But between 2 weeks, we should finish 11.5 and 6. And homework, I already assigned 11.5 first for this week and 11.6 for next week. So if you see something that we haven't talked about in class in 11.5, then it's fine. You just give it a try. Okay, give it a try and even look at the book a little bit. Sometimes it's good to preview a little bit and try to do some problems and then come back and do the lesson. Okay, so like sometimes it's good to go back and forth. So this time I didn't specifically pick the problem, only pick the problems that we talked about in class. I also picked some of the problems that maybe we haven't talked about in class in 11.5 after today. Okay, so give your best try in the homework. Okay, keep up with homework for sure. Okay, all right. So volume of prism and cylinders. Okay, obviously we're gonna explore the method and theory of solving volume of cylinder and prism. And why is it crooked? Cylinder. Okay, today is the 13th. May 13th. Let me see. Okay. So previously we mentioned what a prism is, right? Prism is when you have two bases, one on top, one on the bottom, and they're identical, right? And they don't even have to be upright, they can be slanted. This is still a prism. Now, because a prism is identical top and bottom, like this, right? It's actually identical on every layer. So like, if you cut in any specific layer parallel to the ground, this should also be the same as this, right? This should still be the base. Like if you cut anywhere, it's like a stack, right? It's like a stack of post-it notes. You have opposite notes, right? Opposite notes is a stack, right? It's a stack of the same thing. So if you have that kind of shape, a stack of the same area, then naturally to find the volume is basically how much it's containing. You use base area and then times how many of them. How many of them translate to how high this thing is. Does that make sense? So in general, your volume for any prism is base area times height. Make sense? Say that again. Because these base are all identical throughout the whole solid, if you stack it up, you can make the whole solid, right? If you stack all these triangles up, it will make this solid. So if you think about volume, it really has to do with how much it contains. So it basically is telling you how many of these stacks can I have. So I do the base is triangle times how high this thing is. Okay? So base times height. But this base is base area. Okay? Base area times height. Okay? And if you look at these two special cases, they're still also the same thing. Why? Because this is a rectangular prism, right? So if you treat this as a base, then it'll be length times width is the base area times height, right? So it's the same thing as length times width times height. Okay? Or even if you treat this part as the base, this part as the base, right? Then the height becomes L, right? So it's width times height times L, which is the same thing. Okay? Does that make sense why this volume will be base area times height? Okay? Type yes or no. Or, well, actually don't type yes or no. Give me a number, 1 to 10. How much sense does it make? Eight, 9, 10. All right. So now let's talk about this. So find the volume of a rectangular prism. Obviously, it doesn't look rectangular, right? But remember what defines a rectangular prism. It's the base, right? The base. That means base is rectangle. Okay? So, because this is slanted, right? Because that's how they draw the height. So the base has to be this one. Okay? So volume is base area times height. Base area is what? 3 times 4, right? Height is 1.5, right? That's your height. So multiply together, 12 times 1.5, 18 feet cubed. 3-dimensional, right? 3-dimensional. Okay. All right. Hey, example 2. Remember this? Hexagonal prism. So that means it's a hexagon, right? So we look at the base area. But we learned how to find the base area of a regular hexagon, right? Remember how to do that? Alright, type in the chat. How do I do this? Type in the chat. How do I do this? Type it in the chat. Make 6 triangles. That's good. Alright. So I'll give you some time to find the area of a one triangle and times 6. Okay, remember how to do that? If you don't remember how to do that, go look at the notes. I'll give you 3 minutes, okay? This takes a little more time than the one previously because I want you to review this real quick. This is one of the core concepts from the previous section, right? So, when you're done, put the answer in the chat, okay? So Thomas got 1296. What do you guys think? $12.63. What is it? What is it? So let's take a look. Okay, let's take a look. So first of all, let's look at this triangle. So if you zoom in a little bit, this is 60 degrees, right? Here, I'll write it out. 60 degrees, if you cut in half, is 30 degrees. So 4.5 here. You're gonna find the bottom, right? Find the bottom. So you say tangent 30 degrees. So you go to 4.5 over A. Okay, A, apothem. Okay, so A turns out to be 4.5 divided by 300, so it'll be 4.5 times 3. So apothem was 7.794, right? Right? And then you use that to multiply. So the area is 1/2 base, which is 9, times apothem, which is 7.74994. And then times, there are 6 of them. And then you use this, the volume will be whatever this is times height. Okay? So this turns out to be 210.44. 444. Then you multiply that by 12. I got 25.33. Alright, this is area times 12. This is in VQ. Anyone got this answer like me? Or am I just completely imaginary things? So it seems like, Thomas, your answer is like half of what I had. Does that? Anyone else get this answer? Type in the chat, respond. Or if you found some error that I did, or some part that doesn't make sense, please ask, okay? No reason to hold back. So this is base area times height. Okay? Or I should put B. Okay. Hey, is everyone else AFK or something? How come only Thomas is responding to me? Alright. So, the next piece we're talking about is any question in particular you have, Jacob? John Jacobs, sorry. I call you Jacobs. I see name in the last name and I just pronounced it. Sorry. But John, do you have any questions? Okay, so if you look at this, I took this triangle out, alright, cut into 6 triangle. This one is 60 degrees, right? 60 degrees, cut in half is 30 and 30. And I got 9 originally, but I want to find the apothem, so I want to use this right triangle. Okay, this one right here. If I want to use this right triangle, then it's basically half of what I had, right? So 60 becomes 30, 9 becomes 4.5. And I wanted to get this apothem, so I use opposite of the angle, and adjacent of the angle. So that's why I have to use the tangent, okay? Can't use anything else. Okay? And the rest is just following the trig, and yeah. Okay, so that's why I picked these numbers, and once I get these numbers in, I can find the area of a triangle, I can find the area of the whole hexagon by multiplying by 6, and then multiply by the height to get the whole volume, right? Base area times height. Base area is what we learned previously, times height. Okay. Good. All right, the next part is then, so there's a composite figure. Composite figure means like it's together. This inside part is supposed to be empty, okay? It's empty here. Okay? So it's basically kind of like a, you know, old Chinese money kind of thing. Right? Kind of like that. Right. Anyway, so, by the way, do you guys know, you know, Chinese money, the ancient kind, they look like this? You know why they look like this? Trivia of the day. Do you know why old Chinese money has a hole in there? Arnav, you're right. You want to put a string because they don't have like, because it's really annoying. Like right now, it's probably very annoying for you to carry coins, right? Isn't it? You always have your coins in somewhere that you don't want to hold. That's why people use paper money, because paper money is lighter. But it's really hard to carry coins. For example, you wouldn't carry like 100 quarters on your back, right? That doesn't make sense. So in order to reduce that kind of complexity, they use a string and or some sort of thicker rope or whatever. It's probably a string, and then it goes through, or a chain. It goes through the whole thing, and then they can carry that, tie that onto their waist. That way, they can carry money. And when they need to use it, they just, you know, take it out one by one. Okay, that's why you need a hole. Okay. See, you learned something in geometry today. All right, so the idea of this is basically simple. What we do is we use a cylinder. That's a bigger one, right? We found the volume of the cylinder, subtract the volume of in this case, I think this is a square prism. It didn't say it's a square, but in this case, I think I missed information. Say that this is a square, okay? It's a square. A square. Okay, square. Alright, so. Alright, we're gonna subtract, okay? So, first of all, they tell you this part is 3, right? This part. Okay? So, similar to the previous problem, you need to find the base area first. Now let's analyze this a little bit. So if you have a square, and you know this is 3, how do I find this base? Well, fun fact, you can use the same method as you did previously. 3, 3, right? And then you can find the area of this. Okay? Find the area of this. So, wait. So, this one, wait. Okay. So, the base of this will be, you can do the triangular method if you want, right? I'm writing smaller and smaller. I'm gonna write bigger here because the next problem doesn't require that much space. So this is 45 degree here because it's 90 each, and then this is I don't know what. Oh wait, this is 90 degrees, right? And I know the radius, so I don't even need the apothem. I use base area equals 1/2 AB sine C. Okay? Use this area. Okay? And I can multiply by 4. Times 4. Okay? So, base area of circle is obviously circular area, and radius was 3, right? Same radius, 3. So, the volume will be pi r squared, right? So it'll be pi r squared, height is 5, minus 1/2 3 sine 90 times 4, and then times 5. Okay? So, this is the square. Okay, this is the circle. Okay, and this is the height. 5 is the height, right? All right, so let's calculate. Minus 51.37. So Thomas, you're right. Nearest 10, so 51.4. Very nice. Okay. So, how are we doing? All right. So, last part for prism and cylinders. This is 2 cylinders, right? So same thing, empty inside. So we just use big cylinder minus small cylinder. Make sense? So big cylinder is volume is pi, base area, right? Base area is pi r squared times height is 12 minus this one, another one, pi r squared. H is still 12, right? And that's it. So we just, why does this seems blurry for some reason? Is this just me? Out of focus. Let me slightly pull it a little bit. Okay, so then you calculate it. What you get? 160.9 feet cube, inches cube. Remember to put cube, okay? That's three-dimensional volume, right? Okay. So after we talk about cylinders, I'm gonna take some time to talk about pyramids and cones. Yeah, 12, because the height is 12. After 18 squared, right? 18 squared and 12. Times 12, because the height for both of them are 12. And you want to get the volume, right? So volume is always base area times height. Right. So, if you're okay with this, let's take a small moment to talk about pyramids and cones. Pyramids and cones are basically the same method, except everything is 1/3. So objective is calculate volume, pyramids and cones. Okay, same thing, 13, 20. Okay, so look at it. Everything is the same. So remember, pyramid is when you converge to a point. And same thing, you'll get a height. Okay. This height, notice, is that height is always straight perpendicular to the base. Okay, that's called the height. Okay. So it's the same thing, except there's an extra 1/3. This is true for both prism and cylinder and cones. If you look at the very bottom, there's also a 1/3 in front of it. So it's 1/3 of a prism and it's 1/3 of a cylinder, because cylinder and prism is the same thing, right? Except when you calculate volume, it's about base area times height. So it's 1/3 of each. Okay. Why is it 1/3, not 1/2? Because it is. I mean, there's a proof for this. In the book, I think. Let me see which part. It is a cone. It's a cone, but cone is kind of like a. So let's make a comparison. Okay, so pyramid is to prism is the same thing as cone is to cylinder. Right? Think about it. Right? Pyramid is to prism is the same thing as cone is to cylinder. Because a cone is kind of like a circular cylinder, circular pyramid. Right? Does that make sense? Does this make sense? Alright, so if you are interested in the proof of why this is true, let me see. I remember looking at this. Alright, the exploration of why this is true is on page 635. Okay, page 635. It basically conducts a experiment with sand poured into Prism, and then to figure out it's exactly 1/3. And the actual geometry behind it, they put it in page 636. Okay. Because of limitation, I can't really demonstrate it here, because it requires a little bit of folding and all that stuff. So keep this these pages. So if you're interested in the proof, that's where you can find it. Okay. All right. So let's calculate. So same thing as the previous one. 12 feet, right? So they say the height is equal to the apothem of the base. So you got to find the apothem first. They didn't give you a height, but they say the height is equal to the apothem of the base. So the base is here, right? Hexagonal again. Same method. Right? I'm gonna pull this out. 60 degree again, right? So it'll be 30, and 12 becomes 6, right? All right. Right angle, right? Apothem is here. And they say that the height is also the same thing as apothem, so I'll draw this part here as well. Okay. All right. So here we go. Tangent 30 is equal to 30 degrees is equal to 6 over apothem. So apothem is 6√3. 6√3, which is 10.392, something like that. Okay, and then you do the area, right? Base area is equal to 1/2 base 12 times apothem, 10.392. There's 6 of them, times 6. And the height is the same thing as apothem, so you multiply by the apothem again. 3.392. Okay. But, wait. Alright, let's do one step at a time. Alright. So, let's not do this because this is the only base, right? So we'll do one step at a time. So this is the base for the hexagon, okay? I'll draw a hexagon here. Hexagon the base, right? Base is 1/2 12 times apothem times 6, which is, there's 6 triangles. Okay? So then the volume is 1/3, because this is a pyramid, not a prism. Base area times height. Okay? Height is apothem, so I'll put it here. Base area I'll put here. 10.392. Okay? So let's calculate this base area. So the base area here is 1454.1. Okay, so you put it here. 1454.1. Put it here. Okay, and then multiply out. So I got 5,300. That's our 5,037 point. Didn't say how many. We'll round to the nearest tenth. Okay, feet cubed. Okay, so essentially it's the same exact thing, but it's 1/3 instead of just base times height. It's 1/3 base times height. Okay, 1/3 base area times height. All right. You wanna try one? This is a equilateral triangle, regular triangular pyramid, right? So equilateral triangle, edge length is 12. Okay? Right? Maybe I did it wrong. Hold on. Hmm? Yeah, why is mine so high? Wait, no. No. What? Okay. 1/2 12 times 10.392 times 6. Oh, yeah, 376. 374 is right. 374. Oh my goodness. So then that means get this one wrong. Let me get it white out. Hold on. Okay. Okay. Messed up here. Messed up here. Messed up here. Messed up here. Okay. So 374. And then you multiply that by 1295.9. You guys are correct. Feet, right? Feet cube. Okay? Alright. Sorry about that. Alright, so base area. So this is a triangle already, and it's an equilateral triangle. And the base, they say edge length is 12, height is 10, right? Okay? So you don't have to divide this by 3 pieces because this is already a triangle. What is, so you gotta find the area of this first, and then times height divided by 3. Okay? Divided by 3. Once you find an answer, you can type it in the chat so I know how much you know. And meanwhile, while I'm waiting, can you guys we're gonna take attendance. Let me see if the attendance is up. Yeah, attendance is up. So can we say you're here if you're here? Look, all the AFK people came back. Arvin, is this your regular account? Looks like everyone's here. That's great. All right, so here we go. This is basically one giant triangle, so we don't have to split in more triangles. Okay, it's already a triangle. So, because it's equilateral, right? There's several ways you can look at this. So because they gave you all the length, right? So I know this is 60 degrees. You can either split it to find the bottom, but you don't need to find the bottom here because you already know all the sides and angles. So I'm just gonna use 1/2 A B, right? A B sine 60. I use this a lot for area. The base area equals to that. Right, 1/2 times 144 times sine 60. Oh, I know why it's different because my mode is in radian mode. So you get 62. Does that sound right? 62.3 something. 62.35. 3. Okay. Alright. And then you multiply that by, so volume is 1/3 base times height, which is 1/3 62.353 whatever times 10, right? Times 10. So I get wait. I got 124.7 feet cubed, inches cubed. Does that sound right? Anyone got the same answer? That look right? Oh, you guys. Okay, let's try this again. 1/2 times maybe it's just not my day, guys. Or maybe I have passed down my knowledge to all you guys, so I'm losing knowledge. Or maybe I'm getting old. I don't know. So 62.35, which is this, right? Base area. Right, base area. Do we get the same base area at least? Oh, fail. Okay, divide by 3 times 10. Man. 207.84, okay? Inches cube. Oh, man. Right. So we're clear? Alright. 207.84. Okay. Man, that was Alright. Let's go ahead and look at the next part. So cone, same thing. We were talking about cone, right? 1/3 pi r square h. Same thing. It's 1/3 of a cylinder. Okay. Okay. So let's look at another composite figure. This looks kind of nice, right? They give us information. So this is 40. This is 35. This is 70. So this height must be 70 minus 35, so 35. Okay. Why is it important to find that? Because you need height for each individual, right? Height. So this is 35, 35, 40. Okay, 40, 35, 35. Make sense? Okay, so then the idea becomes simple, right? The top is 1/3 pi r square, r is 21, right? H, 35. Middle one, cylinder, no 1/3, okay? Pi r square h. Last one, right? 1/3, because this is a cone, pi r square h. Okay? So 3 separate solids, add them up, you get this plus this plus this. Okay? So they all have the same radius, same radius, right? And then each one of them, some of them are cone, 2 cones, right? So 1/3 with the cones. Each have their separate heights, right? So you get the heights. So add them up. What do I get? What do I get? 83126.5 centimeters. I always get the wrong units. Centimeters cube. Okay, centimeters cube. Centimeters cube. Make sense? All right. Try the last one. Give you a minute. Try the last one. Oh. So you have 2 different shapes, right? One on top, one on the bottom. So first to top, I get a cone. Cone is 1/3 pi r square h, right? 1/3 pi r square, r is 12, square height is 9. Okay. This one is not 1/3, because it's a cylinder. No 1/3 for cylinder, okay? So pi r square h. Like that. Add them up. Right? Which is Thomas says it's 33929. Do you get similar things? I got the same thing. 33929.2. Yard cube. Okay, we're in yards now. Okay. So, any questions about this problem or anything in particular in this lesson? It's a relatively long lesson because it's kind of like a blend of two two section. Although we're gonna do it again for surface area next week for prism, cylinder, pyramid, and cone. Okay, so this is not gonna be the end of this, but how do you feel about this? It's basically a review for the most part. You just have to remember how to find the base area. And base area is based on based on the previous section, which is the polygon area, which was 10.4 is what you just tested on. Is it? Yeah. Or no, is it? No, it's chapter 11, right? Chapter 11, I think. No, yeah. It's chapter 11. 11.4? 11.3? Something like that. Alright. So, it's based on that, right? Base area is based on that, so you can, you can review how to find base area. Okay. And once you get to base area, you can just multiply by the height or multiply by height divided by 3. You get a pyramid. Okay. All right. Anything else before we go? We just passed an hour mark. This is probably the longest we ever had. Right. Also, I made a lot of errors, so hopefully this is not a constant theme. All right. If you have any questions left, you can stay a little bit, but if not, you're free to go. Goodbye. Feel a little music. Bye-bye.